The list-related operators we studied so far include the square brackets operator, used for list creation, indexing, and element updates, and the del operator, used to remove an element from the list. Next, I'll expand this repertoire with additional operators providing useful functionality. All previously studied operators, as well as those introduced in this lesson, are included in a brief reference manual attached to this lesson as a PDF document. Please make sure you download it, as it'll serve as a useful material once we start writing programs that rely on lists. I'll start by presenting another use of the square brackets operator, meant for list slicing purposes. In this context, the operator allows us to extract a subset of elements from a list and form another list from them. This syntactic construct is formed of a list name, open square brackets, index of the first element to include in the list slice, a colon character, index of the last element in the slice, and closed square bracket. This expression returns a new list containing all elements between index 1 and index 2, where the element at position index 1 itself is included, but careful, the element at index 2 is not included. In other words, index 2 acts as an exclusive upper bound. For example, check out this list of strings, formed of names John, Mary, Adam, Taylor, and Susan. Expression names1:3 returns a new list formed of all elements between indices 1 and 3, including 1 but not including 3. This is to say, all elements at positions 1 and 2. The output of this print statement shows a list formed of Mary and Adam. Notice that the original list is not affected by this operation. When using the slicing operator, a new list is created. Both indices used with the slicing operator are optional. If we omit index 1, it defaults to a value of 0. And if we omit index 2, it defaults to a value equal to the number of elements in the list. Or in other words, to the index of the last element in the list plus 1. So expression names1: returns a list containing all names starting with Mary. Expression names:3 returns a list containing all names up until the element at index 2, which is Adam. And expression names:, where we're omitting both indices, returns a copy of the entire list with all of its elements. Now remember that list indices can also be negative, and in that case the slicing operator behaves exactly as described for positive indices. Here's the same list with its corresponding negative indices. Using expression names-4:-1 returns a list with all elements between -4 and -1, not including position -1 itself. That would be a list formed of Mary, Adam, and Taylor. Expression names-4: where the second index is omitted, returns all names starting with Mary. And expression names:-1, where in this case the first index is omitted, returns all names up until the one at index -2, which is Taylor. The slicing operator is actually so flexible that we can even use it on the left-hand side of an assignment in order to replace a portion of a list with an entirely new set of elements, giving us another list on the right-hand side of that assignment. Here's the syntax for that. We start with a list we want to modify, followed by a pair of indices separated by a colon and in square brackets, where either index is optional. Then we have the equal sign for the assignment, followed by another list containing the element with which the slice will be replaced. Let me show you some examples on the 5-element list of names shown here. This first statement replaces elements 1 through 4, but not including 4 itself, with Kevin and Amy. This affects strings Mary, Adam, and Taylor, and results in the list shown here. Next, we're replacing every element starting at index 2 with Albert and Amanda. This affects Amy and Susan and converts the list as shown here. Finally, we're replacing every element up to the one occupying index 2 and not including 2 itself with Jane. This affects strings John and Kevin and leads to this final state of the list where Jane is included as the first element. From all these examples, you may appreciate the versatile nature of the slicing operator when it comes to extracting portions of a list or partially modifying its content.